Good afternoon, everyone. We're going to get started with the next session. I'd like to introduce Juan Gomez. He's a mobile engineer at Eventbrite. He's going to be talking to us about push notifications this afternoon.
Thanks. So how's the audio? Good? OK, good. Welcome. So thanks for coming. Again, my name is Juan Gomez. I'm a mobile engineer at Eventbrite. And I'm going to be talking a little bit about push notifications, and especially why our current model, not specifically REST, but our current web model, is just not enough for mobile applications. So first, I'm going to talk about what the talk is going to be about so that you know what you're in for. So basically, I'm going to give you a brief introduction to push notifications. I'm going to tell you what they are. I'm going to tell you why you want to be using them. And I'm going to give you a brief rundown, a very high-level rundown, of how to implement push notifications in PyCon and how to leverage a couple of services that make it a little easier, and how to use some projects that will take a little bit of the pain away. What I'm not going to be covering, I'm not going to be covering the mobile side, so I'm not going to be speaking specifics about Android and iOS. There's a lot of stuff that's specific to Google and Apple that I'm going to be covering, but from the server side, not from the mobile side. I'm also not going to be showing a lot of code. I'm sorry to disappoint everybody, but this is labeled as a novice talk, so I'm going to try to keep it as high level as possible. But my objective is that when you leave here, you know where to go, how to start, and where to find what you need to be successful and implement push notifications. So although there's not going to be a lot of code, you're going to know what to do once the session is done. And then some other detailed topics. So I want to start with a question. A lot of us have probably wasted hours of our life staring at this screen. For those of you not familiar with it, it's a tracking page at UPS. So when we have a package, especially a package that we're excited about, we just stare at the web page incessantly, hitting F5, and then waiting for finally seeing the glorious delivery page. But sometimes when this happens, I wonder if there's a better way of doing things. Why do I have to go into a web page, and why do I have to be hitting F5 every time? If UPS knows when the package is delivered, the person that delivers the package has to scan it and put it on my door. So they know that my package has been delivered. Why do I have to be checking on a web page? And this is partly the model that we had for a long time on the web. We always use our browser, and our browser goes to the server and then obtains information, mostly because limitations around how TCP/IP work. But that's the model that we've been used to for years. I just think that it's not very efficient. It reminds me of some road trips that I took as a child, where asking my dad if we were there yet didn't make the trip go any faster. So I think it's time to rethink things a little bit, and especially in light of developments on the mobile side. As most of you know, mobiles are unfortunately not growing. The smartphone use in the world is not growing a lot. It's exploding. It's huge. And the Wall Street Journal put some numbers about 2 weeks ago that really blew me away. Because, and granted, social networks are a little bit ahead of the curve, but these are numbers on the usage on social networks, both on mobile and on the desktop. And as you can see, on most social networks, then the mobile usage is way higher than the desktop usage, except for some social networks. So as I said, social networks are ahead of the curve, but I think all of us, if you're not gathering these numbers, you probably should go back and try to do this. All of us are seeing how our users are increasingly using our service and our website more and more on their mobile device. So I think we need to do more to give them a good experience on their devices, because the old web model that we're so used to, it's really not very efficient for mobile devices. Mostly because mobiles are really restricted, especially on memory, on processing, and on battery life as well. So that model of having to be polling the server every couple of seconds or minutes, if you want, to see if there's new data And most of the time, there's not new data. It's really inefficient, and it gets really evident on mobile, where you're really depleting those precious resources like battery and network. And servers are smart, just like UPS. Servers know when data is there. So if there's something that the server needs to give me, the server knows when that event has happened. And the mobile phone calling the server every 5 seconds or every 10 seconds is not going to make that happen any faster. So there has to be a better way. There has to be a way that servers can tell the phone when they have data for them, and that will make things more efficient, and in turn will make our service a lot more engaging and a lot more pleasant to use for our users. So how do we solve this problem? And the answer, of course, is push notifications, and that's what I'm going to be speaking about. So push notifications are just tiny little text messages that show up on your phone screen. Sometimes they have a beep or a vibration to call your attention, but mostly are small chunks of information that hopefully will be delivered at a relevant time. So for instance, if you're, and I was with some friends not too long ago, and we were wondering, we all have weather apps on our phones, but your weather app tells you, if you check the weather, it tells you what the weather is going to be like during the day, but it never warns you, for example, that it's going to rain. So our phones are smart enough to be able to tell us, hey, it's going to start raining, you should probably head inside if you're outside, or something of that nature. So push notifications make services more engaging and more delightful to use. And they're tiny messages that get delivered at the right time. The architecture is really simple. Basically, there's the provider, which is your service. There's a middleman, in this case, the two biggest smartphone providers, Apple and Google. And then there's the actual devices. On Apple's case, they're extending the push notification model to the desktop too, through Safari. So it's not restricted to the mobile anymore, and you can push information into the desktop using Safari on the Apple platform. So the general high-level architecture is really simple, and then the orange circle here on the screen, it's yours. It's supposed to be your service. The push notification is really, as I said, a small piece of text, and even at the low level, it's still a relatively small piece of JSON. This is a specific Apple push notification, so it has the weird action lock key that basically it's telling the phone what to do when the user unlocks the phone. Those of you that have an iPhone know that your push notifications sometimes show on your lock screen, so we have to tell the phone what to do when you unlock it. So it's a really simple JSON string. That's part of the beauty of push notifications. They're based on the technologies that we already use. It's nothing super complicated. It's stuff that we already know. So they're relatively easy to implement, and they're really easy to implement in Python. So as I say, there's the two big providers for smartphones that are Apple and Google. They have the most robust implementations in the two that we're going to be covering today. So this is a high-level comparison between the two services. So the main difference between the two is that on the Apple side, you have to actually open a TCP/IP socket and then send binary data to Apple for that data to be pushed into the phone. Google has a more, let's say, web-friendly protocol where they use HTTP, and they have recently implemented a new version of their service that uses XMPP, which is what a lot of us know as Jabber, which is just a chat protocol that uses socket as well. Then there's other interesting points on the two services. Security-wise, they're pretty similar, although we'll see that the security side on Apple is a little bit more complicated than on Google. And then the payload, which is the actual message, it's a lot smaller on the Apple side, mostly because on the Apple side, once you send a push to a phone, the operating system is the one that controls the push. On Android, the push gets passed directly to the application, and the application decides what to do. So that's kind of why the payload is a little bigger, or a little bigger on the Google side than on the Apple side. And then finally, there's the how I get errors. Usually when I'm pushing to a lot of devices, there's a lot of, the device could be off, the device could be permanently unregistered from the service. There's many issues that could arise during the execution of your app. So to get those errors back, on the Apple model, you have to have an asynchronous process polling the Apple server through a socket to get the errors back. On the Google model, it's a little bit more friendly again. You get those errors directly when you make your request. So if you're using the HTTP API, you get it on your HTTP response. If you're using the XMPP implementation, you get it on your XMPP response. So it's a little bit easier on the Google side. Push notifications are great, but they also have downsides. The biggest downsides is they're not as reliable as I would like them to be. There's no guarantee that your message is going to be delivered. In most cases, it gets delivered. So in most cases, you do get the message, and you're able to push the message to your users. But there's no guarantee from the provider that that's going to be the case. So you have to be prepared for those cases, and you have to plan ahead. And I guess that's a downside. The other downside is that sometimes if your phone is off, or if you're outside of your area of connectivity, it could happen that by the time you get the message, the data is no longer relevant. So the way both providers are dealing with it is they added an expiration time to the messages. So when you send the message to either Apple or Google, you have to put an expiration time on the message so that they know that after a certain amount of seconds, the message is not relevant enough and it should not be delivered. Because what happens on their side is that once you send the message, they're going to try to keep retrying to deliver the message to the phone until they finally succeed. So first, we're going to talk about the specifics of the Apple implementation. So what you need to get started are an iOS app that's running on the phone. I'm going to tell you a little bit of, why that's an important component. You're going to need a provisioning profile, which is something specific to how you create your app. You're going to need a certificate that I'm going to describe how do you get it. And then you're going to need your device tokens. And the way you get device tokens, it's very similar both on the Apple and the Google side. So I'm only going to describe it here on the Apple side. And you need your payload, of course, which is your message. So how do you get the certificate? The process is not very different from getting a normal SSL certificate. It's just that it's tied to your iOS application. So you basically generate a certificate request. You go to the Apple website where you have your app registered. You upload your certificate request. You tie it to your app ID, and then you generate your certificates from the Apple website. And then with those certificates, you put them on your service, and we'll see in a little bit when you're implementing how your service needs to present those credentials basically to the Apple service before it can start sending push notifications. So moving into the device token is basically, you can think of it as an IP address. It's sort of like an address that Apple assigned a specific app on a specific device. So it's both a combination of a specific phone, so my phone, and my specific app. So let's say my UPS app that's going to warn me when my package finally gets delivered. So that's the device token. And the device token needs to be obtained, since it's specific to the device, it needs to be obtained on the device. So the actual app running on your phone, either your Android app or your iOS app, it's the one that once it gets installed and used for the first time, it has to go and negotiate that device token with the Apple platform or the Google platform, and then get that device token, and it needs to send it back to your service so that you can keep track of the devices and be able to send them messages. So that's a little bit a complicated part, and this diagram covers how that happens. So it's the device, the one that negotiates that token, but then independently, it has to send that token back to you so that you can address that device directly. And then after you have your tokens, then you need to speak directly to the actual Apple server, and that's done through the socket channel that I described, using the certificates that you just previously generated. So it's a normal trust communication as you would do on any TCP/IP connection. So there's a certificate on the Apple side, there's a certificate on your side, and then you both validate the authenticity of those certificates before you start doing you start sending messages, and Apple starts delivering you results of those messages. The best way to do by far Apple push notifications on Python is a little package called PyAPN and PyAPN or PyAPNS. And PyAPNS it handles all the socket connection for you. It handles all the SSL negotiation for you, and it makes writing the code really, really simple. You can go out and find, let's say you have a Django service. There's like Django packages that try to do this. I don't recommend you do that, because since this is a socket connection, both for simplicity reasons and for scalability reasons, and we're going to talk a little bit about it in a couple of slides, it's better to have this as a separate process, and you can run it with PyAPNS a little bit more efficient. In PyAPNS, the source is up on GitHub, and you can download it, you can pip install it, and it's in the cheese shop. So this is the actual code of how you send, how you establish your connection with the Apple server. This is again the Apple side with PyAPNS. So as you can see, it's really simple. You give it a sandbox parameter that by default is true, and what that means is it tells PyAPNS which server to address. When you create your push notification profile on the Apple website, Apple creates a profile both on their test servers and on their production servers. So you can use both depending on if you're testing or if you're already in production. So by making that first use sandbox as true, I'm telling PyAPNS, hey, just try to hit the test servers so that we can do some testing on push notifications. And then I give it the path to my cert file and to my key so that it can negotiate the trust with the Apple server. And then after I've done that, I have two options. The first and the simplest option is just send a single message. And then the single message, you have to use the token. The token is that number, that address that I got from the device. So the device obtained that token and sent it to my server. So I fetch it from my data store, and I use that token to send my actual message. And then the payload, here I'm using a very simple payload. I'm just using a hello world that is going to show up on the phone and beep. But you can use a more complicated payload, and there's ways to doing that. I'm just showing you the simplest case. I can also, and this is a really cool thing on PyAPNS, I can also send multiple push notifications on the same time, taking advantage of a connection that's already established. For that, PyAPNS uses something that's called a frame. So all I have to do is add items to my frame, and each item it's going to be a message. So each item has the exact same components as a normal message. It has a token, it has a payload, and then you can specify more advanced parameters like the expiration that I spoke about a little bit, that tells the server for how many seconds it should keep that message. And then it also, the priority, in case you have multiple messages, you can establish a priority if there's messages that are more important than others. And you just basically, once the frame is constructed, you just send it, and then PyAPNS is intelligent enough to reuse the socket connection that's already established to send all those messages at once. This slide, it's a little bit of a high-level architecture of how I recommend you try to architect your service. As I said, ideally you want your PyAPNS to be running on a separate, it doesn't have to be a separate service, but separate from like your web server or your web application. And then ideally what you could do is you could create queues on your data store that every time an event happens that needs to be communicated to the user through a push notification, those workers, the messages get put on the queue, and then you can have a group of workers, and that is going to allow you to scale to a massive size if you need to. You have different workers that get work from that queue and then send the messages to the Apple or Google server. This architecture applies across the board. So that way, you have a queuing system. Your messages get delivered through the same socket connection. You are reusing your resources, being able to send more messages with the same connection, and that's going to make your service a lot more efficient. And it's going to allow you, as I said, to scale a lot better than if you try to use something like a Django package or something like that. Now I'm going to switch gears a little bit, and I'm going to go to the Google side. A lot of the stuff that we just talked about on the Apple side applies to Google as well. It just has its own little specifics, but the same process applies for negotiating tokens and negotiating trust between the servers. The thing is, on the Google side, it's a little bit easier since this is an HTTP connection. Or on the XMPP side, since it's against sockets, it gets a little bit more complicated again. But then XMPP is a protocol that is widely distributed. So there's a lot of libraries and a lot of documentation to make it easier to implement. So on the Android side, it seems like you need a lot more. But most of those IDs are things that you get either from the Google website when you register your service, or again, the device token that you get from the ID. There's only one thing that's unique, and it's that you need a Google user ID. So anybody that has an Android phone by default has a Google account, but you need to capture that account in order to be able to send them notifications. GCM, as I said in the beginning, has two implementations. There's a very simple HTTP implementation that is just a REST API, and there's the XMPP implementation. I'm not going to go into details of the HTTP. It's really simple to implement. I'm going to talk about two services in the end that are similar, so there's going to be some code that would apply to using the HTTP side. So I'm going to talk more about the XMPP version that's a little bit more interesting. So a good way to do it is using SleekXMPP, which is, again, another Python library that's in the cheese shop. You can pip install it. You can look at the source code on GitHub. But it's not the only one. As I said, XMPP has been around for a long time. There's a lot of libraries, a lot of options, a lot of implementations. I believe some of you might have already used it, so you might have your own preference of what you want to use. But that's the advantage on the Google side, that they use something that we're used to, and it's easy to just pick up the tools that you already have. I'd recommend this one because it makes, again, the code really easy. So this is how you establish the connection again. You just import a package, create the client XMPP, give it your API keys, give it the Google address. You have to use the use SSL equals true, because Google, if you don't, Google's going to reject your connection. And that's it. You have your XMPP connection established, and then XMPP is a chat protocol. So messages are going to be coming back and forth. The biggest downside, for me at least, is that XMPP is based on XML. So all of your messages are going to be wrapped in XML. So that's going to make your payload bigger, and you don't really, I mean, you have to parse it. There's a lot of XML parsers out there. I just think it's a downside since using JSON is so easy that we have this extra layer of XML on top of our messages. But I think it's nice that Google has this kind of chat protocol. The biggest advantage by far is that the XMPP protocol, it's a two-way protocol. So push notifications usually work from the server to the device. But using XMPP, you can send messages from the device to the server, and that opens up a whole new range of scenarios that you don't have, for instance, on the Apple side, or at least not as straightforward as you do on the Google side. As you can see, it's relatively easy depending on the library that you choose, but it's a little bit painful. So fortunately, there's two providers out there, and I'm just going to mention the two that I'm familiar with that have really good solutions that wrap a little bit of this complexity and make it easier to implement push, especially using Python. So the first one is Parse. Parse got acquired by Facebook about a year ago. They do a lot more than push. Push is not their main business. They're basically their service is basically a free backend for mobile developers. So they let you store objects and a bunch of other stuff. But they do push on top of that. They have cross-platform SDK, and the way they do push notifications is through a REST API. So it's really easy. You can use. I'm using HTTP live because I'm trying to keep it the lowest common denominator, but you can use URL live 2 or any other HTTP Python library that you're comfortable with. It's just a post request that you issue against the Parse server. You make a connection. You send the request. The request, again, is just JSON data. I'm using dictionaries here, but all that gets converted to JSON. You send the JSON data over. You can set your headers. Your headers have to have specific tokens that you get from the service. And then you just send it, and then you get back, again, JSON data from Parse. And then Parse handles everything for you and sends the push notifications to the devices. There's a few downsides with Parse. I mean, they're a great service. This is just my experience and my limited experience. So they don't have an official Python SDK, and I think for me that's a downside. We're all Python developers. So they have a Python SDK that they recommend, but it's not very good. And then they have some issues on the mobile side on reliability. So that's something to be wary of. But they're working really hard, and they've come a long way. So they're a really, really good option if you want to abstract all the complexity of the different providers. Another one is Urban Airship. They're really great. They have an official Python SDK that is great. I think on how great their SDK is, it's that maybe the other one, the one on Parse doesn't look as good. But their SDK is great. They have cross-platform support, and it's again a simple REST API. So this is how you implement it. Again, it's really, really simple. You can see that the API is really clean, and this is how you send a message to all types of devices. And this is a very simple message. You see that I don't have to do the JSON on my own like I had on Parse. So it's really, really clean. So in summary, I wanted to paint the picture a little bit of how mobile is basically eating the world. If you're not doing mobile, you're probably thinking about doing mobile. So when you're putting together your mobile strategy, you have to think about push notifications as a way to communicate with your users. It will make your service smarter. You will be able to deliver information at the time that the user needs it. It'll be really personal. It's on a device that the user carries, and it will make your service more personal to the user. And then finally, doing this in Python is easy. It uses standard protocols, and the implementation details are not that hard. And we all have tools already for a lot of this stuff. So that's kind of what I want to talk about. Hopefully you got the gist of it, and especially you got curious about it and are going to go home and look at some of these projects and try to do it on your own. And hopefully we'll see a lot more services offering push in the future. So thank you. So I think we have time for a couple of questions. So if someone wants to come up to the, yeah, you can come up to the mic and.
Yeah, thanks for the talk. I was curious. It seems like you briefly mentioned how there's no guarantees about push notifications being delivered, and I was wondering what the cases are where they're not delivered and how frequent that is and what people should be aware of.
Unfortunately, it's more frequent than I would like. It's getting better as both of these services get more mature. But mobiles by their own nature are not as reliable as any desktop. So the phone could be off, could be out of service coverage. Data connectivity could not be good. All of us know that app crashes your app can crash on your phone at any time for many different reasons if you have memory issues. So those are some of the scenarios in which you could lose push notifications. But it's getting better. I mean, the fact that we have expiration time now, and Apple and Google are working really hard to make this problem go away. But it's something to be wary about. It's not a complete showstopper, but it's something to be
Sorry to follow up really quick, but is there throttling or abuse checks which might lead to?
There is on both sides. I know on Apple you can't send more than 100 messages on one push, or like on one connection, but that's about it. I mean, you can send 100, close it, send another 100. It's not so much a restriction against abuse. I think the abuse part goes more on the Apple policing. Since they have to approve your app before they post it, they police how you do push notifications. On Android, it's a lot more. There's a lot more freedom, but I haven't really seen people abusing it that much.
Okay, thanks.
Okay.
Hi, Juan. Great talk. This question might be out of scope for what you just discussed, but you discussed a few libraries for doing push notifications with Python. Yes. For mobile development. I'm curious if you know off the top of your head good Python libraries for like non-mobile development. For push notifications.
No, those those two serve for push. So you mean for sending push to the desktop?
Yes.
Well, I think the Safari push for Apple works exactly the same as for the mobile. So the same library, PyAPNS, will give you Safari push notification. And unfortunately, we ran out of time. So thank you very much again for coming. And I'm going to stay here and around the conference if you have any questions. So thanks again.